Okay, in this video, we're going to look at titration. We're going to focus on some of the practical things that you need to know, rather than the previous video where it was more focusing on how to do the calculations. Right, so this experiment is you're given a solution of sodium hydroxide here, and you know the concentration of it, and using that we're going to find out the concentration of the hydrochloric acid. Now sodium hydroxide reacts with hydrochloric acid here in a 1-to-1 ratio, 1 mole of NaOH, 1 mole of hydrochloric acid. So we need the equation. Okay, now the first thing you do in the experiment is you suck up 25 centimeters cubed of, this is the NaOH solution here, using this piece of apparatus which is called a pipette. And you need to know the names of these things. And you suck up the liquid with this thing, which is a bulb filler, a safety filler. You suck up 25 centimeters cubed up to the little mark, the little glass mark on it there, and then you transfer the 25 centimeters cubed into the conical flask. And you're going to do the titration in the conical flask. The reason why I use a conical flask rather than a beaker is because it's easy to swirl it and mix it about without spilling it. And that's why you usually do titration into conical flasks. Right, this piece of apparatus here is called the Buret, and they want you to name that properly. It all says in the mark scheme. If you call it a biuret, don't give you the mark for it, because a biuret is a test for proteins that you probably use in biology. So Buret is the right name. It's got a little tap on the end of it, and you dispense the hydrochloric acid from that. You can probably see that this is purple, and that's because it's got an indicator in there, and the indicator is phenolphthalein, and that is purple when it's alkaline, and neutral, and when it's neutral or acidic, it goes colorless. Acidic. Okay, so what you're looking for is something called the end point. Right, so that will stay purple, and you're going to keep adding your hydrochloric acid into it, and add it drop by drop very carefully. And when you get to the end point, it will certainly go with one drop. It will go from being purple to being colorless. And when you get to that, you record the volume of your the volume of HCl you've added to 1.1 centimeter cubed. Graduations of 0.1 centimeter cubed on the Buret. Okay, so that's the practical procedure. And you add it drop by drop. You do a few things that you make sure there's no bubbles in the jet here. Get rid of bubbles. You make sure that you don't get any stuck to the side of the flask here, because if you do, it's not going to go into the flask and it's not going to react. It will make it inaccurate. So you have to bear in mind those sort of things to make it more accurate. Okay, so here's the set of results that you've got now. Okay, so here's the results. Now you can see the first one was 28.9 and the second one 27.8. Now it's only these two, number 3 and 4, that you should use. Number 3 and 4, these are called concordant results. Now concordant results means they agree with each other. That's they're within 0.1 centimeter cubed of each other. And so the person who's done this titration, they've stopped after 4 attempts because they've got concordant results, and you can stop then. If you haven't got concordant results after 4 results, you just keep going until you have, and you must have at least 2 within 0.1 centimeters cubed. And they're the only 2 you use to calculate an average. You ignore all the other ones. Right, there's always marks going for that. So these 2, these are inaccurate. You just don't include them when you're working out the average. You just pick the concordant ones. So here, the average titer, as it's called, that's the amount added, is going to be 27.5 plus 27.4 divided by 2, which of course is 27.45 centimeters cubed. So that's the volume of HCl that's required to react. Okay, now have you seen the previous video? The way I like to do these is to lay out a little table. So, well, first of all, we're going to need this equation. So I'm going to pull that down. This is how we work it out. The concentration is equal to moles over volume. That's what we need. We need that equation. Now we've got two things. We've got NaOH, which I'll do in yellow, and we've got hydrochloric acid, which I will do in orange. And there's the things we need to know about them are, we need to know the concentration, we need to know the number of moles involved in the reaction, and we need to know the volume. Now let's see what we know for each of those. And of course, put them into this equation, and whenever you know two things, you can always work out the third. So the NaOH, well, we are given the concentration of that. That was it says here 0.142. Okay, so that's 0.142 moles per decimeter cubed. We know the volume of the NaOH, that was 25 centimeters cubed. Of course, 25 centimeters cubed, we need to convert into dm cubed, divide by 1,000, that's 0.25 dm cubed. 0.025 dm cubed. Number of moles we don't know yet. Hydrochloric acid, well, what do we know about that? Well, the concentration we're actually trying to find out, so put a question mark there. And the volume of hydrochloric acid, well, here, it's the average titer here, 27.45 centimeters cubed, and that is equal to divide by 1,000 to get into dm cubed, 2745 dm cubed. 2745. Okay, now what we can do is, because we know two things for sodium hydroxide, we know that one and that one, we can work out the moles. So we rearrange this equation. Moles is equal to concentration times volume. So that's equal to 0.142 multiplied by 0.025. That's going to give us a number in standard form. We'll leave it in standard form. Okay, 3.55 times 10 to the minus 3. So put that in there, 3.55 times 10 to the minus 3. Now in the equation, if you remember, it was 1 mole of NaOH reacted with 1 mole of HCl, right, to give us NaCl and H2O. So the number of moles of NaOH are equal to the number of moles of HCl. So we must have had that many moles of HCl in the reaction. Now we know two things. We know the moles and we know the volume. So that means we can work out the concentration of HCl. So the concentration of HCl is equal to moles over vol. Moles, 3.55 times 10 to the minus 3. And the volume, that was this one here, 0.2745 decimeters cubed. So that is equal to 0.1, now put on our calculator, it says 0.1293. Okay, now we should give our answer to 3 significant figures. Okay, so that is equal to 0.129 moles per decimeter cubed, and that's what we set out to find out, the concentration of the HCl. There it is. Okay, so don't forget the key points. Remember the names of the equipment. So it's a pipette and a burette. And remember, when we were working out the titers, we only take the ones that are within 0.1 of each other. They're called concordant titers, and you ignore the others.